I would like to take you through a very gentle introduction to digital design. We have seen in the past how logic can be used for explaining things and proving things in English. What we're to see today is that that same sort of logic can be employed to build circuitry, to do things in digital design to be used for computers. So, first thing we'll see today are three of the basic logical gates, and, or, and not. And then we'll employ those gates to build some circuitry for the expression P and, not Q, or R. Let's look at these gates right now. Here are 6 of the common logical gates, but we're just going to use 3 of them. First one we're going to be using is the NOT gate, sometimes called the inverter. We're going to use AND gate and the OR gate. The other 3 we're not going to be using because they don't occur so frequently in English expression are the NAND gate, the NOR gate, and the exclusive OR gate. Let's do a little example here to show you how these might be remembered. I just came up with something. Here is the AND gate, and my suggestion is that it sort of suggests a D right here in the word AND. Here is the OR gate, and look at this convexity right there. You could think of the O fitting right there in the crevice. Try to remember it that way. For NOT, it's a little bit more difficult, but I've come up with staring at this little circle right here and thinking it's the letter O in the NOT. Alternatively, you could think of the triangle right here and being N-O-T. So those are a couple ideas I came up with for trying to remember which of these gates correspond to which of the logical operators. Let's do a little example right now. We're going to imagine we've got a security light, and someone says they want the light to be on when it is between 8 p.m. and 11 p.m. or if there is a serious storm. So once again, light is to be lit exactly when it is between 8 p.m. and 11 p.m. or whenever there is a serious storm. Define P to represent the statement the time is after 8 p.m., Q to represent the time is after 11 p.m., and R to represent there is a serious storm. Stare at it for a second. We see that we do want the time to be after 8 p.m., but we don't want the time to be after 11 p.m. Remember, we want it to be between 8 p.m. and 11 p.m. So we want this to be true, this to be false, and finally, we would allow a serious storm also to trigger the light. So the expression P and, not Q, or R represents the exact times when we want the light to be lit. How do we build that into our logic? So let's begin. We start with just Q. We want to, in the logical terminology, invert it. We want to NOT it. So we pass it through the NOT operation. We've now got, coming out here, not Q. If we do a conjunction, an AND of that with P, then we have coming out of here, P and not Q. The only thing left that we have to do is to push that through the OR gate with R, and now we have at our end P and not Q or R. In that case right there, that logic would exactly build the light bulb that we want.